Hi class, good job finding this video if you're in my Friday Algebra 1 class. Anyway, today I'm going to be at the Chinese competition in Orlando, and so I will be doing this class using this YouTube video that I created for you. So anyway, let me just go ahead and get started. I think that you're going to find that this seems like it makes sense and is not too hard. You probably figured it out okay. Just give me a moment to show you what it's all about, and we'll do a little bit of practice. At that point, you can go to Big Ideas Math and start your homework. Hopefully, we'll be able to finish everything before the end of the day. So what we're going to be doing today is called graphing linear inequalities in two variables. And so here's an example right here. One thing I want to just remind you too is if this video goes too slow, or if I make a video that's going too slow, remember on YouTube, if you go to the settings, you can actually make it go faster. My voice will sound funny, but it'll allow you to cover the material a little bit quicker. But also, if you get confused, please make sure that you do a little go back a little bit and then replay it until it finally makes sense to you. So don't think that this is just a one play thing. It should be you should be reviewing every once in a while, going back a little bit to have me repeat until you fully understand. And only after you're done with this thing will you be able to go to the homework and be able to understand it. If you went to the homework and it doesn't make sense, it means that you didn't do an adequate job here. So make sure you do a good job on this part so that the homework will make sense. Okay, so we're starting here. We have writing a linear inequality in two variables. It says write a line of an equation that's represented by the dashed line. So if you look here in the middle, if you look here at that dashed line there, the question is what would be the equation of that dashed line? Now that dashed line equation would have a y-intercept right here at -3. So y-intercept is -3, just to remind ourselves. And we also need the slope. Well, the slope looks like it's a rise 1, run 1 type of slope. And that's going to just be rise 1, slope is going to be 1 over 1, which most of you recognize is just 1. So the full equation of the line, if I have slope-intercept form, y equals mx plus b, I'm going to plug in the I'm going to plug in the 1 for the m, and I'm going to plug in the -3 for the b. So y equals 1x minus 3. And that's the equation of that dotted line. So now let's work to the second question, B. It says the solution of an inequality the solutions of an inequality are represented by the shaded region. In other words, describe the solution of the inequality. So in this case, what we have is this shaded region here. The shaded region is underneath the line y equals x minus 3. So it represents all the points of the shaded region underneath this line. So let me tell you what let's go ahead and take a look at what that might mean. So here's the shaded region, and let's see if we can just locate one point inside this region. Before I do that, I want to rewrite this linear equation to represent what I'm seeing in the shaded region. Anytime we deal with a region below a line, we're going to call that less than. So in this case, I'm going to say that y is less than the line x minus 3. Less than means under. In this case. So the idea is that any of the values in that shaded region should solve the inequality. Let me give you an example of a point that's inside that region. So let's take 3, negative 2. So looking inside the graph, you've got the point 3, negative 2. It is in the shaded region. So what I want to do is go ahead and plug that value inside the equation and see if it works. And of course it should work. So let me take this equation and I'm going to write negative 2 for y is less than x, in this case is 3, and then minus 3. Minus 2 is less than 0. Is that true? Well, it is true. So that means at that point, 3, negative 2 did work. You might wonder what's going to happen if I take a point that's outside of the shaded region, say like 2, 3. So if I plug in 2, 3, I'm going to get the following. So 2, 3, it's going to be for y is going to be 2 is less than 3 minus 3. So 2 is less than 0. Is that correct? And the answer is absolutely not. But of course, that's what we would have expected because it is not in the shaded region. So just for the moment, just kind of take some of this in. The idea is that when we deal with linear inequalities, we're going to draw the line. In this case, the dotted line means less than. If the line was solid, we would include that line. It's very much like the hollow dot and the filled in dot that we use for graphing inequalities, like 2 is greater than 3. We use a hollow dot. So we use a dashed line when we don't want to include points that are on that line. We'll use a solid line when we want to include the points on the line. Now that may not be totally clear to you, but it'll be clear to you in a moment. The next question I just have is, it says, name some solutions to the linear equality above. So what I can do in this case is for, well, one point, for instance, is going to be the one we just figured out. It's just 3, negative 2. But any point inside this shaded region, is going to solve. Is going to work in the inequality. For instance, 1, negative 4 is also a solution of the inequality. So the solution to the linear inequality is a whole region, an infinite number of points inside that shaded region. So again, 1, negative 4 would be another example of a point that's inside that area. Okay, so that's just your introduction into linear inequalities. The key thing is to recognize that the equation of the inequality is going to start with the equation of the line itself, and that whether we shade up or down, at the bottom or top, depends on whether it's a greater than or a less than. There are some cases where it may not be so clear, but we'll look at those, and hopefully you'll get them. You'll get enough of those to be able to do the homework. So if you could turn the page. Our first example talks about just checking whether a point works, and we just did that actually in the exploration. So let's go ahead and try these, and then and this is going to be similar to the questions you have in the homework. And it says just plug in these values. You've got an x value here and a y value here. And so let's go ahead and plug them in. 2 times negative 1 plus 9 is less than negative 3. So let's see if that works. Got negative 2 plus 9 is less than negative 3. And I'm going to say that 7 is less than negative 3. Sorry about that call. That was my son trying to get a ride home. Anyway, all taken care of. So does this work? Is 7 less than negative 3? The answer is no. So the question says, tell whether the ordered pair is a solution of the inequality. And the answer is, in this case, it is not. Next, let's try B. And let's go ahead and plug that in. You've got x is 2, so you got 2 minus 3 times negative 2 is greater than or equal to 8. 2 plus 6 greater than or equal to 8. And then in this case it says 8 is greater than or equal to 8. And that would be true because it is equal. So yes. Now I'd like you guys to try, this is going to be, you're going to have questions like this on the homework. And I'm going to ask you to use the pause button on your computer or whatever you're looking at this with. And I'd like you to do number 1. So pause, do number 1. And then when you're finished with it, go ahead and restart the video and see if you got the same answer that I got. Okay, so if you did this one correctly, you should have that it is does not solve the inequality. Minus 2 plus 2 is greater than 0. 0 equals 0 is not greater than 0, so it is not a solution. Okay, move on to number 2, and please pause this video while you try this yourself. Now this one also does not work. If you plug in 0, you get 4 times 0 minus 0 is greater than or equal to 5, and that is also not true. So that point 0, 0 is not a solution. On to number 3. Okay, on this one, we finally get a yes. If you plug in the negative 4 and the negative 1, you should have eventually gotten negative 18 is less than negative 1, and that is correct. That is true. Therefore, that point is a solution to that linear inequality. Last one. Let's do it and see if you can pull this one off. Okay, how'd you do on that? Anyway, I plugged in the 5 and the negative 7. I eventually get 11 is less than 15, and that seems pretty true to me. So that point must be in that shaded region of the solution of this equation. Okay, so anyway, that's example 1. Let's move on to the next page. And in this case, what's going to happen is we're going to be graphing the linear inequality. One thing I just want to remind you is we're dealing with, this is a graph of y is less than 2. If you remember from the old days, a graph of y equals 2 is going to be horizontal and going through the number 2. If I said x is equal to 2, that would be a vertical line going through x equals 2. So just wanted to remind you of those graphs before we got started. Now, let me erase that real quick. And all right, so it says y is less than or equal to 2. Now, when we do less than or equal to, we're going to not have a dotted line. We're going to use a solid line for equal to. But let me graph it first. Y is less than or equal to 2. So here's the number 2. And it's going to be a horizontal line. And I make it solid, a solid line, not a dashed line, when it's an equal to. That means that the line is also, any point on the line is also a solution. So y is less than 2 means we're going to shade below the graph. Less than means below. And there's only one place where that definition gets weird, but that's my shaded region here. Actually, I think I have a highlighter too, so I could maybe use the highlighter to show the area. And again, this is also including the line. So any point that's in this shaded region will solve it. Any point outside of the region will not. So let's move to the next graph, a little bit more exciting. At least it's a little different. What I'm going to do on this is to solve for y, putting it in slope-intercept form, and we'll graph it that way because that seems to be the form that we're much more comfortable with. To do this, I'm going to go ahead. Let me go ahead and rewrite this, and I've got minus x plus 2y is greater than 2. I'm going to try to solve for the y value, so I'm going to add x to both sides. Now I get 2y plus is greater than x plus 2. Now I divide everything by 2. So I'm just treating that inequality, guys, as if it's an equal sign. And if you remember, it acts just like an equal sign until I divide by a negative number, in which case it flips. But in this case, there's no flipping going on. I get y is greater than, it says x over 2. I want you to know that that's the same thing as 1/2 of x plus 1. Think about that again. X over 2 is the same thing as 1/2 of x. Think of like multiplying 1/2 times x and you would get x over 2, right? So I just wanted to pull that fraction out so that we can do the rise over the run. Okay, so let's graph it. We have y-intercept at 1, and we're going to rise 1 and run 2. So this is what we're looking at. And we can get dots on the other side by going down 1 and over 2. And in this case, because it's not equal to, we're going to use a dotted line. So what I've done here is actually, it's actually the finished product in many respects. If you want to make more dashes, you can go ahead and do that. But for the most part, those dots will kind of give us the impression what's going on. This is telling us when it's greater than, it's telling us that the line is not included in the solution. What's greater than? Which side am I going to shade? The top or the bottom? For greater than, think about it. What is it going to be? And I think, yeah, you're right. Greater than means above. So we shade, and I got this nice little shading thing here, I guess. And any point that's on the line will not solve the equation, but any point above will, and all the points below will not. So again, just in review, to graph this linear inequality, we're going to first solve for y and put it in slope-intercept form. I know there's not the equation. It's not an equation. There's no equal sign, but we can treat this this inequality as if it was an equal sign, just making sure to flip it whenever we multiply or divide by a negative number. So let's go ahead and move to the next graph. And I think this is time for you guys to do a graph. So why don't you see if you can't graph y is greater than -1, and pause the video for a moment. See if you can figure it out on your own, and go ahead and look back in your sheet if you want to go back one page and see how I graphed the y the horizontal line in the previous page. Hopefully you'll be able to figure this out. So pause this video for a moment and see if you can't graph this correctly. Okay, so this is what your graph should look like approximately. Did you remember that because this is greater than and not equal to, that the line needs to be dashed? A y is greater than graph is always going to be above. So there it is. I'm hoping that you pulled that one off. Let's go ahead to number 6, but I'll tell you what, don't pause on this one, because there's on this one, this is the only kind of a graph where there's not a definite top or a bottom. And first of all, let's graph x is less than or equal to -4. If you remember from what I said a moment ago, that means it's a vertical line going through -4. And in this case, because it's also equal to, what I'm going to do is I'm going to make it a solid line. Okay, so there is the solid line. Now, it's saying less than. Well, in which direction do we get less than for a vertical line? Of course, there's no top or bottom of this line. It's left and right. But we can still think about the graph, the tendency of numbers being more positive to the right and more negative to the left. So left is less than when we talk about vertical lines. So in this case, what's going to happen is when it says less than or equal to -4, less than will be to the left. So this is the only situation in which it's not top or bottom. When we have a vertical line, less than will be to the left, greater than will be to the right. In this case, also remember that because it's equal to, any point that's on the line will also solve the equation. An example would be, for instance, 4, 2. This number here, 4, 2, is -4, 2, sorry about that, is going to solve the equation. So if you plug it in this case, remember that there's only an x value here, is -4. There's no y value. It's less than or equal to -4. So it is equal to. So that means that that point does work on that line. Anyway, let's go ahead and move to the more generic type of problem, number 7. Now remember, with number 7, what you want to do first is to solve for y and put it in slope-intercept form. Again, the inequality doesn't change unless you multiply or divide by a negative number, so we're fine here. So take a moment and see if you can't pull this one off. Do it by yourself. Okay, so how did you do? This is the solution, and let me show you how I got it really quickly. As I subtracted x from both sides of the equation, and I get the equation y is less than or equal to -x minus 4. Go to the -4, y-intercept, and the slope, remember, is going to be -1, which is the same as rise -1, run 1. So you're going to go down 1 and over 1, and then I made my dots. And then this, because it's equal, it's going to be a solid line. Because it's less than, we're going to shade below. Okay, so make any corrections that you have on that and see if you can't figure out this last equation here. All right, so x minus 2y is less than or equal to 0. Now be careful on this one because there may be a division by a negative number when you do this, and so you need to make sure that you're being able to change the sign. So I'm going to have you pause right now, and when you're done, turn the video back on. Okay, so this may have been a little tricky, but let me show you what I got. I subtracted x from both sides, and once I did that, once I subtracted the x over there, I have a -2y. Now I need to divide by -2, which means I'm going to need to switch the sign to become a greater than sign. Now, take a moment and see if you can figure out how I wrote that -x over -2 as being the same as 1/2 x. Remember, a negative over a negative is a positive, and again, I can just pull that 1/2 out so that it's 1/2 of x. If you need to think about it, remember that 1/2 of x is the same as 1/2 of x over 1, which is the same as x over 2. So it makes sense. I put this little 0 in here because the y-intercept, in this case, you don't see a y-intercept, which means it's 0. So we're going to start we start in the center, and we're going to go up 1 over 2, and that's our line. Because we switched the sign, we're going to shade above that line. Again, that's going to be less than, so the line is not included. It should be a dashed line. All right, so that's where we are with this graph. Let's move to the next page. So pretty much, this is you're going to be able to get through most of the homework from what we've done already. Now, this one here is a problem that I already wrote the solution for. Let me just read it to you. It said you can spend $10 on grapes and apples for a fruit salad. Grapes cost $2.50 a pound. Apples cost $1 per pound. Write a graph of an inequality that represents the amount of grapes and apples you can buy. Identify and interpret the two solutions. So what we're going to do is typically we're going to be using guess for this type of problem, but what we're going to do is in words, go down to here, Guess in this case is what we don't know is the number of apples and the number of grapes that we're going to buy. But in this case, it's an inequality. So let me just show you what we're going to do. If we take the cost per pound of grapes, the cost per pound of grapes was $2.50, right? So if you want just 2.5, the number of grapes, the number of pounds of grapes will just probably be G. Okay? In this case, let me go ahead and use their variables. That's probably makes more sense. We'll call the number of grapes X. The cost for the number of apples is going to be $1 a pound, and an apple is going to be called Y. So if you multiply the price times the number of pounds, you get the amount of money you spent on the grapes. You spend $1 times the number of pounds of apples is how much I spend on the apples. So if I add those two together, that's what's going to give me my $10. So if you look down here, the inequality, right, is right there, 0.25 times the pounds of grape, the number of pounds of grapes, $1 per pound of apples times the number of pounds of apples, Y, and that's going to be less than or equal to 10. In other words, I only have $10 to spend, so I can only spend $10 or less than $10. That's why it says less than or equal to. So an interesting thing here is, so here's the graph. If we graph that equation, we end up getting a graph that looks like this one here. And you'll notice that there are many, many different possible solutions. One of the things that we notice with the solutions for apples and grapes, though, is that typically, because we can't okay, I guess we can have half an apple. But anyway, the number of pound, we can have half a pound of apples. Is at any point in here represents a possible solution. For instance, this point here, this says that I can get 1 pound of grapes and 4 pounds of apples, and I won't spend more than $10. Any of these points in here, 2 pounds of apples and 2 pounds of grapes, that will also be less than my $10. So it's interesting because in a situation like this, we have an infinite number of possible solutions that will allow us to, that will allow us to buy grapes and apples. Now, I know that looks kind of crazy, grapes and apples, who cares? But if you're running a factory, this could also be, yards of some form of material to make pants, or it could be other things that you're working together to create for, you have so much money in your business, and you want to buy a certain quantity of materials to be able to make some product. So that's where you end up seeing this type of modeling in inequalities in the real world. It actually has a lot of business applications. So anyway, that's all I really have for you right now. What I'd like you to do is to now that you're finished, hopefully if you understand it, if you need to, you go back and go through and make sure you understand some of these questions. Hopefully you wrote this stuff down in your notes. But right now I'm going to ask you to go to Big Ideas, and in Big Ideas, I want you to go to the Algebra 1 homework 5.6 and do that. That's going to be your homework for the weekend, and so make sure you understand, if you can finish this before the end of the day, what you can do. I'm not sure what your substitute has in mind for you, but once you're finished, you should be able to work on other classes if you wish. So thank you so much. Hope everything made some sense to you. But go ahead and put on some headphones and listen to some music, and let's go ahead and finish this homework assignment.